So this is question 9 from the 2016 Junior Cert Ordinary Level, Paper 1. The question reads, Ned and Laurie had a race. Laurie was given a head start, so she ran a shorter distance than Ned. The graph below shows the distance along the track in meters that each of them was from the starting line after t seconds of the race. So it's always a good idea first when you're looking at a graph just to think about what's on the two axes. So you've got time in seconds along the x-axis, and you've got distance in meters along the y-axis, the vertical axis. So the first question says, what distance did Ned run during the race? So this is Ned's curve here, and we can see he started at the starting line, 0, and he finished at the finish line, which is 30 on the distance axis. So from 0 to 30, the distance he travelled was 30 meters. Okay, so part B says, what distance did Laurie run during the race? Okay, so Laurie's distance was from this is Laurie's curve here. So Laurie started 5 meters out from the starting line, and then she finished at the finish line. So Laurie went from 5 to 30. So the difference there was 25 meters for Laurie. Okay, so part C of the same question says, how many seconds did it take Laurie to finish the race? So if we go back to the curve, we can see this is Laurie's curve here. How many seconds did it take her to finish? Well, she started at 0 seconds, and if we look down from here, she finished after 10 seconds. Part D says, work out Laurie's mean speed during the race in meters per second. Okay, so Laurie's mean speed, that's her average speed, type of average mean. Speed is distance divided by time. That's a formula you should know. And in our case, Laurie's distance was 25 meters, and her time was 10 seconds. So 25 divided by 10 is 2.5, and that was in meters, the 25, and the 10 was in seconds, so that is meters per second, which is the units they asked for, meters per second. So 2.5 meters per second. Finally, part E says, Ned says, I ran at the same speed for the whole race. Is Ned correct? And give a reason for your answer. So if we go back and look at Ned's curve here, we can see, if we just look at, well, first of all, it's not a straight line. So if he was running at the exact same speed the whole time, as time passed by, he'd be covering the same distance. So this curve would be straight. It would be a straight line, a linear relationship. And we can see that Ned is not doing that. So we can see he covers the first 5 meters in 5 seconds, if you look at that point there. And then as he's going up, you can see he's actually getting faster, and eventually levels out up here again. So the simple answer to that is no, Ned is not correct. And the reason would be the line is not straight. Or you could say the relationship is not linear. Any of those answers would suffice. And that's the only question now.